Lesson 20.3, Task 2. Solve nonlinear systems graphically. A baseball player hits a ball over the left field wall into the stands for a home run. The height of the ball, h sub b, in feet, is modeled by the equation h sub b of x, where x is the horizontal distance from home plate in feet. All right, so you can see the equation there. We're going to get back to that here in just a few minutes. So it says the left field wall is 8 feet tall and 360 feet away from home plate. All right, so you can see different possibilities of home runs being hit. All right, so it says the stands rise at a rate of 7 feet for every 20 feet of run. So that's the rise over run. So that would be the slope in which the stands get taller. And that says with the furthest row being 455 feet from home plate. Determine where in the stands the ball lands to the nearest foot. So the height of the stands can be modeled by the function h sub s of x, and this is our second equation here. So we've got h sub b of x, and this one represents the height of the ball, and h sub s of x is the height of the stands. Okay? All right, and it says for 360, so for all x's between 360 and 455. So this is because the stands are at least 360 feet away. It says right here 360 feet away from home plate. And then it also says that the furthest row is 455 feet. So in order to hit a home run, the domain has to be between 360 and 455. All right, so what does the point 360 and 8 represent in this situation? All right, so 360 would be your x, 8 would be your y value. So what does that represent? All right, 360 feet and 8 foot tall. So it would represent the place in the stands where the ball lands, the top of the left field wall where the stand begins, the distance from home plate to the furthest row. So it would be where the stand begins. All right, so it says solve the following system by setting the two height functions equal. All right, so if we set the two height functions equal, then you could graph those and find the intersection point and determine what the solution is. So it says complete the statement with the correct values. For this system, a solution is possible within the domain of what and what. So again, your x's have to be between the start of the wall and then the highest place of where the stands go. So it's 360 to 455. So this would be 360 to 455. All right, so the stadium seats begin at 360 from home plate and it continues to 455 from home plate. So the domain of the second equation is limited to these values. Okay, so the x's have to be between 360 and 455. All right, so it says the coordinate of the point where the graph of y equals h sub b of x and y equals h sub s of x intersect is the solution of this equation or this system. So graph both functions on the same coordinate plane. So similar to what we did in the last task, you're going to go to y equals, you're going to type in your first function, you're going to go to y equals and type in your second function. You don't necessarily have to enter the domain. You can if you want to. This just shows you like these can't be negative, or this one can't be negative. And then this one's going to be between 360 and 455. So you can see when you look, there is one solution here. Now, if this line continued, it would cross the parabola down here somewhere way down in the negatives, but that would not make sense. So for this situation, talking about home run hits, which is a distance, there's only one solution. So it says the ball will land in the stands with a horizontal distance of 431 feet from home plate and 33 feet above the ground. So you can see if you look at that point, it's always your x and then your y value. So this shows that your x is about 431 and that the y is close to 33 feet. So they've rounded both of those, but that comes from your x and your y value of the intersection point. All right, a linear quadratic system can have up to, so it can have up to 2 solutions because the line can cross the parabola in 2 places, but in this case, it only crosses once. It says, explain why there is only one solution in this situation. Well, again, in this situation, you can't have a negative number down here, so the next time it would cross would be way down here in the negative somewhere, and that would not be a valid solution. So in this case, there would only be one solution, even though there is a possibility of 2. All right, that's all for task 2. If you have any questions, let me know.